Hi, this is Ian McKecken, and I'll just be explaining a problem from my last exam in electronics class. So this is a 5-step problem, and each step, basically what you have to do is you have to draw the output waveform for each of the circuits shown. These circuits do involve diodes, so a diode can inhibit the flow of voltage from the negative or the positive flow depending on how the diode is placed. So let's get started. And just as a reference, every single one of these circuits will have a frequency of 1k hertz. Okay. So for this first one, if we look, we can see that it's inhibiting the positive flow, the positive voltage. So no positive voltage will be able to go through. However, on the negative end, it will allow all of the negative voltage through. So in this case, we're just going to say that positive voltage equals 0 volts and negative voltage is negative 5 volts because it's negative, so that's where the negative sign comes from. Because all of these, it's a 5 volt input. So when we look at the graph, what's that going to look like? Well, okay, so let's say that this right here is 5 volts, and this right here is negative 5 volts. Well, so we know that on the positive end, nothing's going to happen, so we'll just draw a straight line to show that. And then on the negative end, we have negative 5 volts. Then back on the positive end, where another straight line. And then back on the negative end with another negative 5 volts. And as you can see, that's what the graph will look like. Okay, and moving on to part 2. So with part 2, it's a little bit different. It'll block the positive voltage, as you can see, because this end of the diode, and then it'll also block the negative voltage. So unfortunately, it doesn't look like there'll be any voltage flow through the circuit, so we're just going to say total voltage is 0 volts. And for the graph, that's pretty easy because we just have to draw a straight line through 0, like that. Okay, now for part C, if we look at this, we can see that positive voltage will go up through here, up and around. Negative voltage looks like it's going to get stopped. So once again, we'll just say voltage positive equals 5 volts, while negative voltage will be 0 volts. Okay, and for the graph, same thing. All you're going to do is say that's 5, negative 5. In this case, again, since the negative is not going to be working, we'll have it go to 5, then nothing for the negative, then once again go to 5, and then once again nothing for the negative. Okay. Moving on to part 4. This one is mostly resistors. So the positive flow is going to go through. If we look at, it'll go through the circuit. It'll go through the circuit, through here, and out of the output. The negative voltage, because of this 1k ohm resistor, that'll get cut in half, so only half of that will actually leave. So in that case, we can say, again, Vp positive equals 5 volts, and Vp negative equals negative 2.5 volts. Okay, so moving on to the graph part, what does that look like? Well, we know that there's our 5 here, we have our negative 5 here, and now we're just going to add a small dot for 0.25 or 2.5 volts and negative 2.5 volts. So again, positive, it's just going to look like this. Negative, it's only going to go down to the 0.25. So it's not going to go all the way down to 5. Back up to positive and back down to negative. Okay, and the final one, if we look at that, we can see that once again the positive voltage will go through, but the negative voltage has to go through the resistor, and that will be cut in half. So okay, so it's actually the same as the previous one. Positive voltage is 5 volts, and negative voltage is negative 2.5 volts. Okay, moving on to the graph. And again, like I said, the graph is going to look exactly the same as the previous one. So we're just going to add the 2 dots and 5, negative 5, or negative 2.5, 5, negative 2.5.